Good morning, class. Our topic today is the law of sines and its application. This is one of my favorite topics in trigonometry. I hope you will like it also. First, let us consider this oblique triangle. It has three consecutive acute angles. We start with acute angle alpha, followed by acute angle beta, and this is followed by acute angle gamma. We also have three consecutive sides, A, B, and C. Okay, so these three consecutive acute angles and three consecutive sides follow the exact order, as the adjective word consecutive implies. Now, you can actually rotate these parts in a clockwise manner. You can even have the counterclockwise manner. So whether you have the clockwise or counterclockwise rotation, you have to take note of the particular orientation. Okay, as what I have said earlier, uh, the acute angles follow the particular order, the exact order. Same with the sides A, B, and C. Whenever you have the acute angle alpha, its opposite must be side A. Whenever you have the acute angle beta, its opposite must be side B. Whenever you have the acute angle gamma, its opposite must be side C. Okay, we can even have the reverse. Whenever you have side A, its opposite must be acute angle alpha. Whenever you have side B, its opposite must be acute angle beta. And whenever you have side C, its opposite must be acute angle gamma. Having that orientation in mind, let me present to you the formulas related to the law of sines. This is formula 1. This is formula 2. You can choose one of these formulas to solve the missing measure of an acute angle or a side. Let us recall the transitive property of equality. If we apply the reverse technique of this transitive property of equality, we'll be able to break down each formula into simpler equations, like this one. Formula 1 is broken down into three simple equations. Same with formula 2. Now, math majors, try to supply the particular values for three variables of a certain simple equation and leave only one unknown variable. So if you do that in formula 1 and in formula 2, you will have these conditions for the law of sines. Without these conditions, you cannot readily apply the law of sines. First condition, there must be given measures of two sides and one measure of the acute angle opposite one of them. Second condition, there must be given measures of two acute angles and one measure of the side opposite one of them. Now, let's have the sample applications of the law of sine. This is a real word problem. And let me illustrate this word problem by this drawing. Okay, by this image. Okay, so according to the word problem, a large helium balloon is tethered to the ground by two taut lines. One line is 100 feet long and makes an 80-degree angle with the ground. The second line makes a 40, this is the second line, this makes a 40-degree angle with the ground. How long is the second line? So the first question is the length of this second line. How long is the second line? And the second question is, how far apart are the theta's? So the second question talks about this side of the oblique triangle. Okay, so let's have the solution for the first question. Let x be the length of the second line. So before arriving at the solution, we need to decide the values for alpha, beta, and gamma, and with the sides a, b, and c. So after deciding the values for these variables, okay, so we can proceed to the solution. So as you can see in the solution, we have decided already that alpha equals to 40 degrees and side A equals to 100 feet. Then we can also see that beta equals to 80 degrees and side B equals to x, the unknown. Okay, so to solve the unknown, let us apply the cross multiplication for this simple equation. So after the cross multiplication, okay, a certain condition will take place in such a way that this quantity x is being multiplied to this quantity, that is the sine value of 40 degrees. In the right hand side, 100 is being multiplied to this single quantity, that is the sine value of 80 degrees. To further solve for x, we need to divide both sides of the equation by the sine value of 40 degrees, and that will leave only x in the left hand side. In the right hand side, this product here that is already in the right hand side is being divided by the sine value of 40 degrees. Using the scientific calculator, the value of your x will be equal to 153 feet. That answers the first question. Let's have the solution for the second question. Let y be the distance between theta's. So you can see that still acute angle alpha equals to 40 degrees, side A equals to 100, and we also see that gamma equals to 60 degrees, and side C equals to the variable y, the unknown. So to solve this one, same with the first solution, let us apply the cross multiplication here in this simple equation. After the cross multiplication, a certain condition will take place in such a way that in the left hand side, this quantity y is being multiplied to this single quantity, that is the sine value of 40 degrees. In the right hand side, we already have this product, and this is the product of 100 and this value, which is the sine value of 60 degrees. Now to further solve for y, let us divide both sides of the equation by the sine value of 40 degrees. That will only leave y in the left hand side. In the right hand side, this product that is already in the right hand side is being divided by the sine value of 40 degrees. Using the scientific calculator, the value of our y is 135 feet, and this answers the second question. Amazing. Law of sight is really amazing. Now, math majors, later I will give you the word problems to exercise your application application of the law of science.